So moving on from that frequency distribution, what we're going to talk about now is cumulative frequency distributions. And the cumulative frequency of a class is the sum of the frequencies of that class and all previous classes. You can think of this like with a final. If you have a cumulative final, that final includes what you did in the last chapter and every chapter before. If you have a cumulative midterm, that midterm includes everything you've done up to that point. So a cumulative frequency is taking the frequency of that class and every class before it. And cumulative relative frequency, we're just going to divide the cumulative frequency by the total number of data values that we have, right? The sum of all frequencies in this case. And so let's go ahead for that same fast food data. We're going to go ahead and create a cumulative frequency histogram. Or first, a cumulative frequency distribution. Now here's our table for the cumulative frequency distribution. We're going to start this very much the same way. From 0 to 4, we had 15 fast food meals, and we ended up, if you remember, rounding down. That won't be such a concern here because my cumulative frequencies won't add up to 100, and so we could just leave it as 41 if we were going to compare this data with data we had before. Probably leaving it as 41 would be good. People would wonder why it suddenly changed to 42. And so let's go ahead and do that. Leave this as 41, leave it rounded down, even though rounding rules would have had us round up. Now, what we're going to do for the next class is it's not going to be from 5 to 9. It's going to be from 0 to 9. Which means, remember, from 5 to 9 I had 13, but I'm also going to add the 15 I had below to get a cumulative frequency of 28. So you can see what this is kind of saying is, exactly what it's saying is, how many people had 9 or less fast food meals? How many had 4 or less fast food meals during the week? And so the next will be from 0 to 14. Okay, and we had 3 or 5 additional people, so we can take our previous value of 28 and add the 5 on for 33. From 0 to 19, now looking at our previous frequency distribution, we had 1 additional person, 34, 35, 36. 1 additional person in each category. And so I'm just plus 1, plus 1, plus 1 to get to the next category. Now we'll have to recalculate our cumulative relative frequencies. We'll do 28 over 36 and 33 over 36 and so on to figure out the cumulative relative frequencies. Of course, 36 out of 36, at the very end we should be at 1. So these are the values that I calculate here. And so that's a cumulative relative frequency distribution. You can see pretty straightforward, and we'll end up using something like this here shortly. Now here is some new data. We're asked to construct a frequency histogram from this data. But what I want you to think about is when we do this, how are we going to set up the classes? That's kind of an interesting question here. We already have the data. We don't need to create a frequency distribution, I would say. But when I go to set up the classes, what makes sense to do here is to have 0 and then 1. This is an extremely rough graph, don't judge it too harshly. we'll make a better graph down below. And then 2, okay, and so this needs to be much higher if I'm going to be accurate, but we want that number to be right in the middle. But here's what I want you to think about. If I put the number right in the middle of my frequency histogram, what does that make my class width? Now, obviously, the class width is 1. I've got 0, 1, 2. There's only one kind of number of children per family. But this is kind of an interesting way we can think about this, is that my class is actually from negative 0.5 to 0.5. And if you look at the graph, I think you can actually see that. 0 is right in the middle. My class width is 1, so I'm going 0.5 below 0 and 0.5 above 0. And so we don't necessarily have to, write those class widths out when we do this. But I just want you to kind of be thinking about that if I was to set up a distribution here, make a distribution out of this data, out of this table, my class widths would actually look like this, so that my class midpoint could be 1. And that would be the high part of my table, or not the peak of my bar. The center of the bar right there would be right at 0, right at 1. So what I'm going to do is go ahead and pause this, take a minute, and construct a frequency histogram using this data. So here's my frequency distribution, or frequency histogram, based on the distribution we were given. I want to highlight something and slap myself on the wrist here and hopefully kind of emphasize this fact by having done that the number of children, in the previous graph, I never labeled the x-axis. Kind of just not being careful, because we had been talking about the fact that it was the number of fast food meals eaten in the past 14 days. But really, anytime we're making a graph, we should label the x and y axis, so that people can look at that and see what exactly are we doing. What is it exactly that we're looking for? What is this information describing? Without those numbers, then it's hard to tell what's going on. Now, I'll go ahead and put out there that we were given some data here about the number of children and the frequency, and without a title to the graph, and we don't even know, what this came from. We were just asked to make a histogram, but without the title, it's hard to tell also what's going on. So, if I don't have enough information, it's kind of hard to tell what exactly is happening. And so the more information we can put on a graph, the better. I also want to highlight, as I've just been talking about, the fact that my classes are really starting at 0.5. This would be negative 0.5. This is 1.5. That my class width is 1, but my class endpoints are kind of odd numbers. But it works out, kind of that's something that happens in the background, because as we look at this graph, you don't notice that fact, more than likely. But as somebody who's making the graph, we should notice that we're purposefully choosing class endpoints so that the class midpoint will be 0, and that's the high point here. The class midpoint is 1, and that's the highlighted feature on this graph. So let's apply that vocabulary that was at the bottom of that last page to these graphs. So looking at these graphs, I would say this first graph, let's go ahead and I would go ahead and say that graph would be something that is unimodal. It only has one mode, one high point up here. I would also call this approximately symmetric, based on the fact that on the two sides of this graph, it pretty much looks the same. There are some subtle differences, and I'm not going to argue that, but it's approximately symmetric. This second graph, top right corner, this would be something that we would call uniform. It's not exactly uniform, but it is approximately uniform. Everything has approximately the same value. Now here on the bottom left, here's another unimodal graph. And same thing on the bottom right. But we would say that this graph in the bottom left corner is left skewed. Okay, left skewed because we've got kind of all this information on the left-hand side, all this data on the left-hand side before we get to the mode. And so as you might imagine, we call this graph in the bottom right corner of the screen here, right skewed. Now notice the mode is on the left, but then we've got kind of all this extra information that occurs, all this extra data that occurs to the right of the mode. Now looking at these on this screen, at these top two graphs, I would call both of these unimodal. And we would call this top left graph J-shaped. And sometimes this graph that's on the top right is called reverse J-shaped. Now I would call both of these graphs on the bottom bimodal. They have two high points. Notice on this graph on the right, they're not the exact same high point. It's not the exact same number, but there are two high points. I'd call those two graphs bimodal. And this graph on the top, or on the bottom right, I would call a U-shaped graph. Okay, also bimodal, but it's kind of got a U shape to it. Closely related to frequency histograms is something that we call frequency polygons. You can see here on the left-hand side of the screen, we've got a frequency histogram. Okay, now notice that you might notice that the class endpoints are kind of odd in this. I want to just point out that the reason that those are kind of different here is, well, that'll help us with what we're about to do, because the class midpoint, if I average those 2 points, okay, ends up being 8. So sometimes that's why we might have these really odd class endpoints, 5.5, 10.5, 15.5. So that we can, my class midpoint is smack dab in the middle, it's 8. And also you can notice that if I had, for example, discrete data, 5.5 makes it very clear which, like kind of, instead of having to do something like 0 to 5.999, the 5.5 makes it very clear with discrete data that what's going to fall into this class would be anything like 6, 7, 8, 9, and 10. And so the reason sometimes we use these odd endpoints like 5.5 is because it makes it very clear what discrete values go in those classes. So, that's just kind of something to pay attention to. You might notice that you see that sometimes and wonder why they do that. But like I said, one of the reasons is so that we end up with 8 as our class midpoint. If you compare this frequency histogram for runner's times, it's a relative frequency histogram in fact, and then look off to the right, the way that we make a frequency polygon is just by taking the midpoints of all those classes and then just kind of playing, connect the dots here. Notice we're even taking the 3 right here and the 43 over here on the right. And then if we just connect the dots, we end up with a polygon that looks like the polygon over here. So a frequency polygon sounds terrifying. Remember, a polygon is just a shape with several sides, straight lines for the sides. And so that's what we've got here, is just this, you know, if you want to think of it as 1, 2, 3, 4, 5, 6, 7, 8, 9-sided shape. It's a polygon. Okay, that's the only reason that we call it a frequency polygon. But notice it's not really a big deal. It's just taking the class midpoints at the top middles of those bars and connecting the dots. Now, just as a reminder, to find the class midpoints, you take the lower class limit of one class and the lower class limit of the next class, and you average them. So like I had in the previous screen, I'd taken 5.5, 10.5, added them up to get 16, divided by 2 to find the average, and I got 8. So we could actually make a fast food frequency polygon based on the fast food data that we have used before. And I'm going to ask you to go ahead and do that using the information that we already had. So here's what I've got for my frequency polygon so far. Notice that I just used the midpoint of the class. Notice I didn't label it on the graph. 2.5 for the number of fast food meals doesn't make sense. So I just used my original labels, but I made sure that I put that dot at the midpoint. And so what I'm going to do now is just connect those dots. And there's my frequency polygon. I want you to notice that, to redeem myself here, I went back and labeled my graph with the number of fast food meals, and even gave my graph, part of a title. I mean, if I could say, within 14 days of November, of 15th, for section blah, 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 blah. I think that's probably a little too much information to be giving on this graph. But an appropriate title can go a long way to help us understand, because you can see if I don't put that title here, number of fast food meals is a true and appropriate label, but the within 14 days makes that make even more sense. Closely related to a frequency polygon is something called a frequency ogive. Now, a frequency ogive is just a frequency polygon where we're using cumulative frequencies. And then we could have a relative frequency ogive also. And the only difference there is we would be using relative cumulative frequencies. And so one last use of this fast food data in this lesson, we're going to go ahead and plot a relative frequency ogive using the data that we used previously. If you remember, we had actually constructed a cumulative frequency distribution If you remember, we've already constructed a cumulative frequency distribution for this data, so we'll just go back to that cumulative frequency distribution and use it to make our relative frequency ogive. So take a few minutes to start working on that. And if you feel like you're getting stuck, then you can go ahead and watch and just kind of copy what I'm doing. But if you start working through that on your own and then get stuck, I think that it will go a lot further to kind of watch the rest of the video once you get to a point that you're not sure what to do. Now I've got my graph here mostly labeled, but I want to talk about the labeling of the y-axis a little bit. Because this is cumulative relative frequency, I know that my y-axis is going to go all the way up to 1. And so I want to make sure that I include values going all the way up to 1. Because I know at the end I'm going to get to 100%. So when I label this, I might label this 10% at a time, 0.1, go up in increments of 0.1 or maybe 0.2, and I think I'll do increments of 0.2 for this graph. And so now as I start this, I'm looking at my cumulative frequency distribution from earlier in the lecture, earlier in the notes here. Okay, so I'm looking at my cumulative frequency distribution from earlier in the notes here, and I'm noticing that we started at 0.42. And remember, I'm going to use the class midpoint for this. So that's really 2.5. I don't want to label the 2.5s. I don't think that makes a whole lot of sense in terms of looking at this and saying somebody ate 2.5 fast food meals. But I am using that value when I put this dot on my chart right above 0.4. Then for the next class, it was 0.78. So I'm going to go to about 7.5 and have a dot at about 7.5, pretty close to 0.8, 0.78. And then I was at 0.92, so fairly close to 1, and that's going to be at about 12.5. And then 0.94. And then 0.97, and then 1. Okay, so just kind of trying to make my ogive here, and now I can just connect those dots that I put on the graph. And so this is an example of a frequency, a relative frequency ogive, where I'm using those cumulative relative frequencies, and just a frequency ogive would just use the cumulative frequencies. So, if I wanted to redo this as just a cumulative frequency ogive, all I would have to do is come through here, and maybe I would make this would be my 36 right here. Remember, there were 36 total, and I know it's going to end at the max because it's cumulative. And then I could go back and relabel my axis, and I would have just a cumulative frequency ogive, whereas this is a cumulative relative frequency ogive.